some of it get refracted, it will get transmitted to the second medium. Okay? If I polish this surface, then the possibility of reflection will get cancelled out and all the light will get reflected as we do in the daily mirrors. Okay? If I polish one surface, then it will get converted into a mirror. Now, if this medium is rare and the second one is denser, it will get, see, this is the actual path of the light. If there would not have been any medium, it would be traveling in this particular direction. But now, as it is going into a denser medium, it will take a shorter path. Since the shortest path is the normal path, but it will take a shorter path towards the normal. This angle will be angle of refraction, this is angle of incidence. One important relation between the angle of incidence and the reflection and the angle of reflection that we should keep here in mind is that the angle of incidence is always greater than angle of reflection in the case when the light is traveling from rare medium to the denser medium. Because the time is constant, the light has a constant time to reach the same destination, so it takes a shorter path. Because the molecules here are closer and the traffic here is more, so it takes a shorter path. Okay. Now the second case, here I is always greater than R. The limit for I will say, it will be from 0 degree, minimum 0 degree to maximum approaching to 90 degree. From this is 0. Normal, maximum it can reach 90, further it cannot exceed. Okay, we should keep this particular thing in mind in order to understand the conditions for TIR, which I will be discussing later. Okay, I will always be greater than R. Now we will consider the second case in which the light will be going from the denser medium towards the rarer medium. This time the light will go from the denser medium to the rarer medium in the normal. This is the incident ray making an angle I. It will get, since the medium is rarer, the molecules are separated and the time is constant, so it will take a longer path, so it will get refracted away from the normal. It will get refracted away from the normal. Here this is R, this is I. I here will be always less than R in case of dense to rare. Now in the second case, I am exceeding this angle I and I will see that the reflection will be even more. From here I conclude that R is proportional to I. R is greater than I and it is also depending on I. Now in the third case, if I exceed it even more, a time will come when if the angle of reflection as R is proportional to I, so increasing I, a moment will come when R will become 90 degree. At that moment of time when the angle of reflection will be equal to 90 degree, at that time the angle of incidence will be called as angle of critical angle. Okay. Now, if I even increase the angle of incidence, okay, this way, and even more, if I increase it, then definitely since R is proportional to I, then R will exceed even then 90 degree in this case, something like this, and at this time it will not get refracted, it will get totally internally reflected. And since it is reflection, so it will obey the laws. The angle of reflection, this R is angle of reflection, this was angle of reflection, this angle of reflection will be equal to angle of incidence. This is the phenomena of total internal reflection. As I told, there are three possibilities: reflection, absorption and transmittance. In this particular case, again the possibility of transmittance and reflection has been cancelled out. Here I have shown only you the reflection, but also some portion of the light, some energy of the light is even getting reflected. But here all the even getting reflected, but here no reflection is there. All the light energy is getting totally internally reflected. That's why we say that there is no loss of energy in total internal reflection, and that is the purpose. That's why we use the phenomenon of TIR in optical fibers, because we don't want any energy to get wasted. Now, conditions for TIR. First condition, as it is visual from here, that at I is equal to IC, the light get refracted at an angle of 90 degrees. So, for TIR, the angle of incidence incidence should be greater than angle of critical angle. And the second condition is that light should always go from denser medium to rarest medium. Because when the light will be going from rarer to denser, since R is smaller than I and the limit of I is only 90 degrees, therefore R will never be 90 degree, and so therefore there is no possibility of R exceeding 90 degree. That's why it will not get totally internally reflected, it will only refract in that case. That's why the second condition that it should go from denser to. Is it sir?
Simulation or anything?
Simulation.
I will just mention that